Good afternoon to all. I am P. Suganya, Department of Mathematics, Dhanalakshmi Srinivasan Arts and Science College for Women, Autonomous, Perambalur. Now we are going to see the topic graph theory. Introduction to graphs. Definition: a graph is a collection of points called vertex and collection of lines called edges. Each of which join either a pair of points or a single point to itself. Mathematically, graph G is an ordered pair of vertices and edges. Each edges Eij is associated with an ordered pair of vertices Vi and Vj. In figure of G has 4 vertices, namely V1, V2, V3 and V4, and 7 edges, namely E1, E2, E3, E4, E5, E6, E7. Then E1 vertices pair of V1 and comma V2. Similarly for other edges. In short, we can represent G equal to vertices of edges, where V equal to V1, V2, V3, V4 and E equal to E1, E2, E3, E4, E5, E6, E7. Self-loop and parallel edges. Definition: if the n vertices Vi and Vj of any edges Eij are same, then edges Eij is called a self-loop. For example, in a graph G, the edge E6 equal to V3, V3 is a self-loop. Next definition: if there are more than one edges is associated with the given pair of vertices, then those edges is called a parallel or a multiple edges. For example, in a graph G, E4 and E7 has V3, V4 are called a parallel edges. Simple and multiple graphs. Definition: a graph that has neither a self-loop or parallel edges is called as simple graph. Otherwise, it is called as multiple graph. For example, G1 graph is a simple graph, another one G2 is a multiple graph. Weighted graph. If each edge or each vertex or both are associated with some positive number, then the graph is called a weighted graph. Finite and infinite graph. A graph is a finite number of vertices as well as finite number of edges is called a finite graph. Otherwise, it is an infinite graph. For example, the graph G1 and G2 are finite graph. Next definition, we are going to see a graph G equal to vertices of and edges is called a labeled graph. If it is edges are edges labeled with some names or data. For example, graph G is a labeled graph. Adjacency and incidence. Two vertices V1 and V2 vertices of G joins directly by at least one edges, then their vertices called adjacent vertices. For example, in a graph G, V1 and V2 are adjacent vertices. Next definition: Vi is the end vertex of edges of Eij equal to Vi and Vj. Then edge Eij is said to be a incident on Vi. Similarly, Ei is said to be an incident on Vj. For example, in a graph G, Ei is a incident on V1 and V2. Degree of a vertex. The number of edges incident on a vertex Vi with self-loop counted twice is called a degree of vertex Vi. For example, consider the graph G, d of V1 equal to 3, d of V2 equal degree of V2 equal to 2, degree of V3 equal to 5, degree of V4 equal to 4. Next definition: isolated vertex. A vertex with the degree 0 is called a isolated vertex, and a vertex with the degree 1 is called a pendant vertex. Next definition: null graph. If the edges set of any graph with the n vertices is an empty set, the set graph is known as null graph. It is denoted by nn, for example n3 and n4. Next definition: complete graph. Let G be a simple graph on n vertices. If the degree of each vertex is n minus 1, then the graph is called a complete graph. Complete graph on n vertices, it is denoted by Kn. In complete graph Kn, the number of edges are K1, K2, K3 and K4, K5. Regular graph. If the degree of each vertex is same say R in any graph G, then the graph is said to be a regular graph of degree R. For example, K3, K4, K5. Next graph, bipartite graph. The graph is called a bipartite graph if the vertex set V can be partitioned in two distinct subset of V1 and V2 such that V1 union V2 equal to V, V1 and intersection V2 equal to empty. And also each vertex of each edges of G is joined at a vertex of V1 and vertex of V2. A graph cannot have a self-loop. G1 is a bipartite graph. No, because there is no way to partition the vertices into the two sets of, so there are no edges with both endpoints in the same set. Next, G2 is a bipartite. Yes, because we can display G2 like this. Next, subgraph. A subgraph of a graph G equal to vertices edges is a graph G dash equal to V dash comma E, where V dash contain V and E dash contain E. For example, G1 is a subset of G2. Thank you.